For centuries, humanity has looked toward the night sky and asked one of the most profound questions imaginable. Are we alone in the universe? Every star visible to the naked eye could host its own family of planets. With hundreds of billions of stars scattered across the Milky Way alone, the possibility that life exists elsewhere has fascinated scientists, philosophers, and dreamers for generations. Today, that timeless question is no longer limited to speculation. It is being explored with the most advanced scientific instruments ever built, led by the James Webb Space Telescope. Launched in December 2021, the James Webb Space Telescope was designed to study the earliest galaxies, uncover how stars and planets are born, and examine the atmospheres of distant exoplanets with a level of precision never before achieved. Unlike the Hubble Space Telescope, which primarily observes visible and ultraviolet light, Webb specializes in infrared astronomy. This allows it to detect the faint chemical fingerprints hidden within the atmospheres of planets orbiting distant stars. Among its most fascinating targets is K2-12B, an exoplanet located about 124 light-years from Earth in the constellation Leo. Discovered in 2015, K2-12B orbits a cool red dwarf star called K2-18. The planet measures roughly 2.6 times Earth's radius and has a mass about 8.6 times greater than our planet. It belongs to a mysterious class known as sub-Neptunes, worlds larger than rocky planets but smaller than the ice giants found in our own solar system. Because our solar system contains no planet quite like K2-18b, astronomers are still trying to understand how these unusual worlds form and evolve. Although the planet circles its star at a distance of only about 0.15 astronomical units, it receives enough energy to lie within the star's habitable zone, where temperatures may allow liquid water to exist if the atmospheric conditions are favorable. Its size, location, and intriguing atmosphere have made K2-18b one of the most important exoplanets ever studied in the search for potentially habitable environments. Interest in the planet increased dramatically after observations from the James Webb Space Telescope revealed an atmosphere containing water vapor, methane, and carbon dioxide. These discoveries were made using a technique called transit spectroscopy. As the planet passes in front of its host star, a tiny portion of the starlight filters through its atmosphere. Different molecules absorb different wavelengths of light, leaving behind unique spectral fingerprints that astronomers can identify with remarkable precision. The simultaneous detection of methane and carbon dioxide is especially intriguing because it matches theoretical predictions for a hydrogen-rich atmosphere surrounding a vast global ocean. If this interpretation is correct, K2-18b could represent a completely different kind of habitable world, one unlike Earth, yet still capable of supporting certain forms of life. However, the observation that captured worldwide attention involved a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced mainly by microscopic marine organisms such as phytoplankton. Because there are currently no known large-scale non-biological sources of DMS on Earth, scientists consider it a potential biosignature. Webb detected an extremely faint signal that researchers suggested might be consistent with either dimethyl sulfide or a closely related molecule known as dimethyl disulfide. It is important to understand that this detection remains preliminary. The signal has not yet reached the statistical confidence required for scientific confirmation, and astronomers continue to stress that additional observations are essential before drawing any conclusions. Even if future observations confirm the presence of DMS, researchers would still need to determine whether unfamiliar geological or atmospheric processes on an alien planet could produce the same molecule without life. Extraordinary discoveries demand extraordinary evidence, which is why the scientific community continues to treat these findings with cautious optimism rather than certainty. Another reason K2-18b has attracted so much attention is the possibility that it belongs to a newly proposed category of planets known as Hycean worlds. The Hycean concept, introduced by astrophysicist Niku Madhusudan and his colleagues, describes planets with hydrogen-rich atmospheres covering enormous global oceans. Unlike Earth, these planets may have no continents at all. Instead, their surfaces could be covered entirely by deep oceans lying beneath thick atmospheric layers. Although such worlds would be dramatically different from our own, they may actually increase the number of potentially habitable planets in the galaxy. Thick hydrogen atmospheres trap heat efficiently, allowing liquid water to remain stable across a much wider range of distances from their stars than on Earth-like planets. Their relatively large size also makes them easier for telescopes like James Webb to observe, improving our chances of detecting important atmospheric molecules. If microbial life can survive under these conditions, Hycean worlds could become some of the most promising places to search for extraterrestrial biology. At the same time, many important questions remain unanswered. The internal structure of K2-18b is still uncertain. Some researchers believe it may contain a deep ocean beneath its atmosphere, while others argue it could instead consist of superheated water, high-pressure ice surrounding a rocky interior, or even resemble a miniature Neptune without a true ocean surface. Its parent star also presents another challenge. Red dwarf stars are known for producing powerful stellar flares capable of altering planetary atmospheres over billions of years. Whether K2-18b has remained stable enough to support long-term habitable conditions is still being actively investigated. These uncertainties do not reduce the importance of Webb's observations. Instead, they demonstrate how much remains to be learned about planets unlike anything found in our own solar system. Regardless of what future studies reveal, K2-18b has already transformed the search for life beyond Earth. For the first time, scientists are analyzing the atmosphere of a potentially habitable exoplanet in extraordinary detail instead of merely confirming that such a planet exists. Future observations by the James Webb Space Telescope will provide more accurate measurements of methane, water vapor, carbon dioxide, and other atmospheric gases while searching for additional molecules that could reveal the planet's true nature. Upcoming observatories, including NASA's proposed Habitable Worlds Observatory and the extremely large telescope now being built in Chile, will push these investigations even further, allowing astronomers to examine nearby exoplanets with unprecedented sensitivity. Whether K2-18b ultimately turns out to host a vast ocean, a hostile atmosphere, or conditions favorable for microbial life, it has already shown that the search for life is entering an entirely new era. Instead of simply asking whether planets exist around distant stars, scientists are now beginning to investigate what fills their atmospheres and whether those environments might support biology. Every new spectrum collected by James Webb brings humanity one step closer to answering one of the oldest questions ever asked. We have not discovered alien life on K2-18b, and no responsible scientist claims that we have. What we have found is an extraordinary world whose chemistry challenges current theories and whose atmosphere deserves continued investigation. If future observations strengthen the evidence for potential biosignatures, K2-18b could one day become the first world that guided humanity toward discovering life beyond Earth. Until then, it remains one of the most exciting and scientifically significant planets ever studied, reminding us that the universe is far more diverse, far more complex, and far more mysterious than we once imagined.